Hello everybody and welcome to the second part of the notes. This is notes over 3-6 distance. This is part 2. We're going to go over one example in which we find the distance between each pair of parallel lines. We have a little grid here to graph these, so let's graph this line. In red, have a y-intercept of -3, and we go down 1 and to the right 3. So let's connect those dots. Go, and we'll do the other one in green. Looks like we have a y-intercept of 1/3, so I'm going to approximate where that is, about there, and from there I go down 1 and right 3 once again. They have the same slopes, therefore they are parallel lines. We can see that from the graph right there. Okay, now, to go about finding the distance, we need perpendicular transversal that will cut through both of these. We're going to start out by choosing a relatively easy point on one of the lines, and right here the y-intercept on the red line comes to mind because it's right there in the crosshairs of the point 0, -3. Alright, here's what else we know. We know the slopes of these lines are -1/3. Perpendicular slope to those would be +3/1, or just 3. Okay, so I have a slope, and I have a line I want to make through that. So look here, from this point I will go up 3 and right 1. Let's make that point a little more visible. Okay, if I connect those two lines right there, I will have a perpendicular transversal. And that's very important because that will tell me the distance between those two lines. Remember, the distance between lines or segments or points is found by a perpendicular line. They have to be perpendicular. That makes the shortest distance. And I'll show my little perpendicular symbols here. Now I need an equation of this line. What is the equation of this line? Well, I have a point and I have a slope up here to work with, 3. So why not use slope-intercept form? We know that to be y equals mx plus b. Alright, the slope is 3, and I already know this is a y-intercept of -3. So y equals 3x minus 3. Alright, and then what I need to do next is determine what is the coordinates of this point right here. Now let me get this to show up. There we go. I need to know this right here. Now from the graph it looks like 1, 0, but we need to verify. On the other examples we'll need to verify that. So if I'm at 0, -3, that's that point. I need to know this coordinate right here so I can get that distance. I'll leave a little space for that. Eventually I will find the distance between those two. Okay, so I need to set up where these two intersect, where the green line and the black line, and that, again, that black line has the equation y equals 3x minus 3. I need to know where those two intersect. So what I'm going to do is use a substitution method to solve systems. I'm going to take this 3x minus 3 and set it equal to -1/3 x plus 1/3. Okay, so here's what we have. 3x minus 3 equal to -1/3 x plus 1/3. Alright, now I need to solve this and I'll know where the x-coordinate of the point of intersection is going to be. I'm going to clear my fractions. Notice my fractions are 1/3 and 1/3. I can clear fractions by multiplying everything by 3. This will give me 9x minus 3 minus 9 equals -x plus 1. Okay, and then I'm going to add x to both sides to get 10x. I'm going to add 9 to both sides to get 10. Now it looks like x equals 1. Alright, I need to know the y-coordinate, so I'll plug it back up in here to find a y-coordinate. 3 times 1 minus 3 equals 0. So now I got my coordinates now. I know 1 and 0 are the coordinates, and the only thing left to do is to apply the distance formula with those 2 points.